In this example, we are going to write an equation of the form Cx equals a cosine of omega x minus phi plus b for the cosine function whose graph is shown below. This is going to be very different than the previous cases where we have graphed functions of sine and cosine. In this case, the graph is already provided to us and we need to pick out the pieces that construct this. That means we need to determine from what we were provided what the amplitude, the vertical shift, the period change, and the phase shift are. If we could figure out all those, then we can make an equation in this form. However, what I'm going to do with this, unlike what we did before where we took the x and y coordinates and then we applied the amplitude to the y coordinates first and then the vertical shift, and then for the x coordinates we did the period change first and then the phase shift, I'm actually going to go in the reverse order. I'm going to deal with the shifts first and then I'm going to deal with what the amplitude and the period change are. Let's start with the vertical pieces first because those tend to go a little bit simpler. I'm going to start with the vertical shift. The vertical shift is how much the baseline or the midline has been moved. Originally, the midline for the function is at the x-axis. We need to find where the new midline of this function is. The midline should be halfway through the function that we have provided. In this situation, the halfway point vertically for this function that goes down to -3 and up to +1 would be here at -1. If you have a hard time finding that, you should also be able to take the average of those two. The average of -3 and 1 is -1. This is my new baseline. That means that that is also my vertical change, my vertical shift. So b will equal -1 here. The amplitude then is also not too bad. The amplitude is the height of the curve from the baseline or from the midline. Now, the height of the curve you can read from the midline up to the peak or down to the trough. Either way, we can find that the amplitude is a distance of 2, either from -1 up to +1 or -1 down to -3. You could technically consider the amplitude to be a negative if you read it to go down. However, it tends to be far simpler to simply consider the amplitude to be a negative value and adjust accordingly for the other pieces. So in this case, I'm going to say my amplitude is that it goes up 2, so my amplitude, the height of it, is 2. Those are the vertical pieces. Note that I didn't do anything horizontal. I just looked at how tall the curve was and where it was shifted up or down. Now let's do the horizontal concepts. Just like with graphing though, I am going to consider an adjusted version of this equation. Instead of a cosine of omega x minus phi, I'm going to consider a cosine of omega times the quantity x minus phi over omega. What I have now done is isolated the effects of omega, which is the period change, as well as the phase shift. Because when I do find the phase shift of this function, the phase shift is not just phi. The phase shift is phi divided by omega. Again, like with vertical though, I am going to start with the shift. The shift is how much the function is moved left or right. Now, how to determine how much it is moved left or right? What I'm going to do is consider that the original function for cosine normally looks like this. This is what cosine of x looks like. It starts high on the y-axis at 1 and then goes down, meaning we typically read it from the peak of the curve and then move down from there. So what that means is that I'm going to determine my phase shift, the horizontal shift, based on where the peak has been moved from the y-axis. In this case, looking at our curve here, we have a lot of different peaks to choose from, and that actually means that you have multiple different solutions you can have for the phase shift. If I, for example, choose that I have moved from the y-axis over to the right this much, in this case, that amount would be a distance of pi thirds based on the x-axis here. That means that I would define my value of phi over omega as pi thirds. That would be my phase shift. If, however, you chose a different phase shift, then you are going to have a different value for phi over omega, and your equation is going to look slightly different. However, as periodic functions tend to work, there are multiple ways of denoting that because you can start from many different places. If, for example, I wanted to consider starting back over to here, and that means phi over omega is negative pi thirds. And that is fine as well. Or if I wanted to choose another point, maybe all the way back here, well then now my period change now my phase shift is negative pi. Again, you will get a different looking answer, but it will equal the same thing. The period change, on the other hand, the period change, though, is not as malleable. The period change is supposed to be read as how long it takes the curve to repeat itself. And you can try to read how long it takes to repeat itself from many different places. I usually suggest to just read either from a peak to a peak or a trough to a trough, and if necessary, maybe somewhere along the midline to somewhere else along the midline. In most circumstances, though, you can typically just see how long it takes to get from one peak to the next. That distance from one peak to the next is going to be your period. In this case, I have a peak at pi and a peak at pi thirds. So that means my period is pi minus pi thirds, or 2 pi thirds. Note that I'm saying the period is 2 pi thirds. I'm not saying that 2 pi thirds is omega. That is not true. Omega is not the period. Omega is the period change. In order to find the period, what we normally would do is take omega and divide that away from the typical period for this function. So what that means is that we would normally do 2 pi divided by omega, and that equals your period. So that would equal 2 pi thirds. You may need to do a little bit of math there then in order to solve for omega. In this situation though, omega is pretty simply just 3. Meaning I have all the pieces I need for my adjusted function. I have phi over omega, I have omega, I have A, and I have B. One other note about omega. Yes, you can indicate the omega value where the period is a negative. That would just read it backwards. Typical convention, though, is to try to keep the period to be positive. So, using these values, we have, therefore, that c of x is equal to A, which is 2, times cosine of, if I'm using my adjusted function up here, omega is 3. Phi over omega is pi over 3. And B is minus 1. This gives me, therefore, 2 cosine of 3x plus pi, or minus pi, minus 1. And that is my final answer.